Good evening. Our final two tests. The ratio test and we have the root test. Both involve examining a limit. They both have the exact same outcome. The only difference is what's the limit we're looking at. For the ratio, limit of the absolute value of a sub n plus 1 over a sub n. And for the root test, we're looking at the limit of the nth root of the absolute value of a sub n. Here's what the tests say. If rho is less than 1, the series converges absolutely. If rho is greater than 1, the series diverges. And if rho equals 1, the test is inconclusive. The series could either converge or diverge. Of all the tests we've looked at, these two are the most powerful. Ratio also happens to be the most useful. We'll be using it again. Determine whether this series converges.
Can we go back a little bit?
I could.
The last screen.
So notice the test doesn't give us a required starting point. Right? Can start anywhere. It also doesn't state whether the series has to be alternating or positive. It works on both. Let's use ratio. We're going to do n plus 1 term. Divided by our n term. Absolute value. Right. Henceforth, I'm going to skip that first step. I think of it that way. A sub n plus 1 times the reciprocal of a sub n. That's how I'll be writing it from now on. All right, so there's the n plus 1. Reciprocal of our n. Now the idea is to simplify this. N plus 1 factorial squared over n factorial squared. How does that simplify? Ultimately, it boils down to how does n plus 1 factorial over n factorial simplify? N plus 1 factorial. N plus 1 times n factorial, isn't it? Then we have n factorial over n factorial. It's 1, isn't it?
Yeah, so it would just be n plus 1 with that one.
Simplifies just n plus 1, right? But the whole thing was squared. So it's n plus 1 squared. Over 2n factorial over 2n plus 2 factorial.
that be, would that be plus 1 times 2n factorial? Can the bottom something get factored out? Or?
No, factor is the wrong word. It is rewritten.
In a way that it would have an n plus 1.
Remember, how is factorial defined? It's the product of successive integers, right? Be 2n plus 2 times the integer before it, 2n plus 1, times the integer before that, which would be 2n, times the integer before that would be 2n minus 1. If you look at 2n and then all the integers after that, or before that, it would just be 2n factorial. Right, so 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n factorial. Now you have a 2n factorial over it.
I mean, I know you can factor out a 2, and then you have an n plus 1 at that first term. And then maybe
True.
Cancel out at the top.
It's not necessary. You can do that. Not really necessary for our purposes. Yeah, we want to do that. So I'm going to do. You are not going to let me move you, are you? N plus 1 squared. Always positive, right? 2n plus 2.
For n starting at 1 is always positive.
It's always going to be positive. Again, doesn't even matter that n starts at 1. We're letting n get very large. So we don't care about all the starting values. N's going to be extremely large positive. So 2n plus 2 is going to be positive, regardless of where n starts. 2n plus 1, also positive. Positive divided by positive. It's positive. We can just drop the absolute values. What's that limit?
Is it going to be 0?
How'd you get 0?
Well, I figured it was shrinking because it looks like the value on the denominator is a little bit bigger than the one on the numerator.
Is it though?
N plus 1 times n plus 1 over 2n plus 2 times 2n plus 1.
For very large n, are they really that different?
Multiplied by 2. So what the limit just ends up being 1?
The bottom is larger, but not by much. Not enough to make it go to 0.
That's like a fraction or something. Is it 1/2?
Closer.
Is it
It's a quarter. Degree of the numerator is 2. Degree of the denominator is 2. So you have to look at the ratio of the leading terms. Coefficient of the numerator is 1, right? Coefficient of the denominator is 4. It's 2 times 2. Because you have to distribute the 2n to the 2n.
Oh, because that's what it would look like if it was actually.
As a polynomial.
Okay.
It's less than 1.
So it converges absolutely. What happens to the factorial signs, though?
They round up simplifying out.
Oh, they like if you have one numerator and denominator like that, and
These ones round up simplifying out.
okay.
That's why the ratio test is so powerful. It gets rid of factorials. So our series does converge absolutely by the ratio test. Limit of the absolute value. N plus 1 term. Times reciprocal of the nth term. Two n plus 2 factorial over 2n factorial. We just saw how that should simplify. Remember, 2n plus 2 times 2n plus 1 in the numerator. Yes. What about n to the 4th over n plus 1 to the 4th? Does that simplify?
It's going to be 1. That would end up being 1 over some kind of polynomial.
That doesn't simplify.
It doesn't simplify.
I mean, just that's going to be a polynomial of a polynomial. You could theoretically do long division on it. There's no point. Two n plus 2, positive. 2n plus 1, positive. N to the fourth, positive. N plus 1 to the fourth, positive. Absolute values just disappear. What is that limit? That limit's infinite. So what do we think? Series converge, diverge?
Well, that seems to be, I guess, another thing's not really a number. So if it amounts to infinity, that counts as greater than 1. Okay.
No, because if you take an infinitely large number, it's going to be larger than 1. So technically, what this should say is if rho is greater than 1 or infinite, it diverges. But we typically just say larger than 1 because we understand infinity to be larger than 1. So limit of the absolute value. N plus 1 term. Times the reciprocal of the n term. And remember, I'm using common notation. N plus 1 cubed over n cubed, is that going to simplify? What about natural log of 2 to the n over natural log of 2 to the n plus 1? What does that simplify to?
Just 1 over natural log
2.
The 2 of
N plus 1 cubed, positive. N cubed, positive. Natural log of 2, obviously positive. What is that limit? Is that a rational function that we're taking the limit of? Polynomial divided by a polynomial. Is that what we have? Why do you say no?
I think there's a term on the bottom that doesn't match anything on the top.
What term? What's the natural log of 2? Is it a fixed value? It is, isn't it? So isn't natural log of 2 a coefficient? The limit's 1 over log 2. Right? The denominator is a polynomial. Log of 2 is a number. Right? Nowhere in the definition of polynomials did it say that the coefficients had to be integers or rational numbers. They could be irrational numbers as well, right? Your coefficients are real numbers as long as it's a number. Actually, by the way, your polynomials can also have complex coefficients, but that's for a different course. Now the question is 1 over log 2 greater than 1, less than 1, or equal to 1? Well, it's clearly not equal to 1. So is it greater than or less than? About 2.7. I think it's 2.781, something like that. It's less than, no. The denominator is going to be less than 1. Yeah, it's larger than 1. Log of 2 is ever slightly less than 1. But less than 1 nonetheless. The series diverges by the ratio test. Oh, the ratio test is easy.
So I can do a convergence.
I could. Doesn't mean I will. You failed to mention what real quick means. All you have to do is be good at algebra and be able to take limits for ratio tests. Well, I guess then know whether a value is greater than or less than 1. That could be challenging.
In some cases.
Limit, absolute value. What is our n plus 1 term?
The n to the n plus 1.
Just that?
Over n plus 1 factorial.
What would our 1 over a sub n be?
Would be factorial of e to the n.
Now, let's try and simplify this. 3 to the n plus 1 over 3 to the n.
What was maybe
1 over 3?
Actually, I think it's just 30.
Yeah. What about n factorial over n plus 1 factorial?
1 over n plus 1.
Yep, just 1 over n plus 1. Well, 3 is positive. N plus 1 is positive. What's that limit? We like 0. That is obviously less than 1. We have absolute convergence. Four to the n over n plus 2 to the n. Well, can't we rewrite that as 4 over n plus 2 all raised to the nth power? Well, that's not geometric. Can't be because the denominator is n plus 2. However, it does give you a clue to use the root test. Your entire term's being raised to the nth power. So look at the nth root of the absolute value of our a sub n. I'm just going to write it as it was given. 4 to the n over n plus 2 to the n.
Doesn't cancel out 8?
It will. I'm going to use a property of absolute values to pull the nth power outside the absolute value first. We're left with that limit. Four of n plus 2 is always positive. And what's that limit?
0.
Which is less than 1. We have absolute convergence by the root test. This is really the only scenario where the root test is useful. Is if you have a term being raised to the nth power. N over n plus 1 all raised to the nth. Well, again, there's a huge clue here. Use the root test. So we're looking at the limit of the nth root of the absolute value of n over n plus 1 raised to the nth. And you can factor out the nth power, which leaves us with just the absolute value of n over n plus 1. That leaves us with the limit of n over n plus 1. And that limit is what? What can we conclude? Test is inconclusive. So we have to try something else. What do you want to try next? A lot of our tests aren't going to be fun. Let's look at this limit. If I do e to a log, you just get whatever we're taking the log of, right? So I haven't really changed anything. E is continuous everywhere. So composite function theorem says I can do this. Right. Limit of f of g, as long as f is continuous at your limit of g, then that limit's just f of the limit of g. That's the composite function theorem. Since we know E is continuous everywhere, it's going to be continuous at that limit. That's the limit we're looking at then. So we just have to look at this limit. Well, using laws of logs, we can write it that way. That is essentially infinity times infinity, though. Which is indeterminate. Oh, no, I'm sorry. It's not infinity. It's infinity times 0. Infinity times log of 1. Which is indeterminate. You can't. L'Hopital's rule is only for two forms, 0 over 0 or infinity over infinity. This is not either of those forms. It doesn't work for infinity over 0. It's only 0 over 0 and infinity over infinity. Those are the only two indeterminate forms acceptable for L'Hopital. Isn't n 1 over n? Now, limit of the numerator is 0. Limit of the denominator is 0. We now have 0 over 0. we can now use L'Hopital's rule. Before I do that, I'm going to rewrite it. It just makes taking the derivative easier. So remember what L'Hopital's rule says. You take the derivative of the numerator over the derivative of the denominator and then take that limit. What's the limit of the, oh, I'm sorry, not the limit. What's the derivative of the numerator? What was it?
The derivative
Of the numerator.
Right. Since it's ln,
Right.
it will be 1 over whatever.
Forgot chain rule.
Oh, is it?
Which is why I wrote it. That's the difference. So I don't have to worry about quotient rule. Because if you use this, chain rule would force you to use quotient rule, which I don't feel like doing. So I'm just going to look at this form. Because the derivative of n plus 1 is just 1. What is the derivative of the denominator? Back out the negative. Still a problem here. This is infinity times 0 as it's written, which is indeterminate. Let's try writing it as a single fraction though and see what we get. We're going to have a common denominator of n times n plus 1. And what are we going to be left with in the numerator? It's just 1. N plus 1 minus n is in the numerator. What's that limit? That limit is 1. N squared over n plus 1. N squared over n squared plus n. Polynomial over polynomial. So we have negative 1. Going back to here, oops. This limit was negative 1. So that's e to the minus 1. What test did I use?
We try to do.
I already used the test. I'm asking which one I used.
Oh. Oh, we did the root.
Which was inconclusive, and then I did a test after that. What test is this? That's the divergence test. What does the divergence test say? You can give me either form. Is E inverse 0? We diverge by the nth term divergence test. You're asked to determine whether a series converges. There is no correct way of doing it, but there is a general strategy. First, try the ratio or the root test. If that is inconclusive, try the divergence test. If that is inconclusive, ask yourself if it's a positive series. If it is, try comparison, either direct comparison or limit comparison. Or, as a last resort, the integral test.
Would that be somehow wasn't a positive series?
No, integral test is only for positive as well. Integral test is only if comparison tests are too difficult. Like it's way too difficult to determine a series to compare to that you know convergence or divergence of. If it's not a positive series, there's only one alternative. It's an alternating series. Check for absolute convergence. If it does converge absolutely, you're done. It converges. If it fails, then you use the alternating series test. However, I can most certainly guarantee if it's an alternating series, the ratio root test is inconclusive and the divergence test fails, it's going to converge. You just have to prove it using the alternating series test or absolute convergence. Those are all of the tests. An assessment may not be nice enough to tell you what test to use. Exam 3, for instance, may not tell you what test to use. It'll just give you a series and say, does it converge? Your job is to determine whether it converges or diverges and back up your answer with the appropriate test. Right? It's never good enough to just say yes or no, converges or diverges. You have to always back up your answer. This is true regardless of what math course you're taking. It's just it hasn't been as obvious as it is now. Right? Before you're asked, find volume of this surface of revolution. You didn't just write down the volume, right? You actually showed your work. That's backing up your answer. If you take linear algebra, you may get true or false questions. It's a little bit misleading because there's no such thing as true false in math. You always have to back up your answer. So it's if true, prove it. If false, provide a counter example. That is backing up your answer. If you give me just converges or diverges, 1 point out of 10 if it's correct. The other 90% is your work. The backup to your answer. And this is why a lot of students find this to be the most difficult part of Calc 2. Actually, specifically, the most difficult part of the calculus sequence in general. Because unless you've taken discrete math already, This is your first look at abstract mathematics. And this is not as abstract as linear algebra is going to be. Questions on series in general? Because that's what your third exam is on, right? It's all series. So then here's what I'm going to do. The My Open Math set is due on Wednesday. The third exam is due on Wednesday. And you have the video that's due on Wednesday. Use the rest of this time to complete that. See you Wednesday.